All right.
That's good.
So we saw these before, blah, blah, blah. So I'm going to blow through this really fast because we're so far behind. It's not really that critical. Don't use the old TS stuff. Use the new SWOC stuff. Try to use the libswoc IP instead of inc inet. I am working on getting rid of inc inet. The IP address is just better. All the problems with lexicon were C++ compatibility, and the fundamental problem is here. That changed from not a valid initializer for string view to a valid initializer, and this confused the lexicon constructors. And there's some various workarounds. All right. So we talked about some of this before. So I'm going to go through this. Tokenizer, hate it, hate it, hate it. Use text view instead. If you're going to need the original text, don't break it up into pieces. Store the original view, the single original string, and have views into it. Whenever you're building APIs, don't use const standard string. Use string view or text view for your parameter. It means that you can use different types of input. Again, we talked about you can then use arbitrary buffers. You don't have to have a string. And don't require C strings. Doing that generally means someone's going to allocate memory somewhere. So get used to just doing views and everything and keeping track of the length. Right, great. So here's control base. This is the new version. What we do is for the multi-text mod, we take the value that came in, we stuff it in a standard string. We then do some parsing here and store a bunch of views into that, rather than making what you previous did is it allocated for every single little subtoken.
Hey, Alan, can I interrupt you quickly here?
Apparently.
Yeah, I did anyways. Would you be a darling and maybe make some comments or something in the code that you said telling us not to use? I'm never going to remember that, right? Obviously.
All right.
Can you put some comments or something saying, hey, deprecated, use this instead, SWOC : foo, right?
All right.
So there's a place somewhere we can actually see what the hell we should be doing.
All right. I'll try to do that. Anyway, so this is control best is getting rid of stuff. So the previous one, this is the previous one. It used tokenizer, which does allocations by itself just to do the parsing. So we're already allocating memory there. It then goes through and it string dupes every one of those little tokens and sticks them into the vector. So we're doing the range token initialization. We're doing every token here is getting allocated. This one allocation. Well, two actually, but the other one did two too for the vector, the text vec. So this one's doing the text calculations and the string dupes and the range thing, and we reduced that to 2 here. So it's just better, and the code's a little cleaner too. So yeah, look at using Memorina. It's kind of a replacement for arena.h, but it's just so enormously better than that. You should use it. It actually has static memory support, so you can give it a static block that comes from anywhere, and it will use it, but not deallocate it when it's instructed. So this means you can use some stacked memory, and if that's big enough, you can avoid allocation entirely, even though you're using Memorina. So this is really nice. And oh, that should be vectray, not split vector. Anyway, and you can, in the intrusive dlist can be used to put lists if you don't need random access. You can put a intrusive dlist in the Memorina, and then again, you're really reducing the total number of allocations that you're using. So IPAllow does this. We have this function IPAllow called localize, and we have the non-standard strings. The config has one Memorina. So every time we have a non-standard method, we localize into that arena and then keep a view of it. So even if we have dozens of non-standard strings in various places, we're really only doing one allocation in the Memorina, and then we're sticking all these little views in there. So that's an example of how you can use a Memorina with views to minimize stuff. What I'd like to do, and this is one of the things we can discuss, I'd like to add a Memorina to HPSM, so that internally we can use the arena for all of these little local strings that we need that we're malloking now. We can just put them in the arena, leak them until the transaction ends, and then they get all cleaned up. And I'd like to make this available to plugins. So if a plugin needs a string for the duration of a transaction, it can call this, get n bytes of memory. It doesn't have to free, and it gets cleaned up naturally. There's a bunch of API that allocates memory, and then you have to remember ATS free. I'd like to add parallel ones to say, no, use the transaction local memory, and it'll just get cleaned up when we're done. And again, so I'd like to do that. Does anyone think this is reasonable? Should I put a full proposal up to do this? Yes? No? I can't hear anyone.
I'm not sure.
I would say yes.
Well, okay, so when you, I mean, I guess to ask a broader question, now that we're switching to these allocators that have thread local pools, does that diminish the value of Memorina? Does it kind of get into being like a free list type thing where we're kind of trying to optimize in a specific way something that we've optimized in a general way?
Yeah, I think it reduces the usefulness of it because you're not getting much global contention, but it's still, the memory allocation is still a lot cheaper than even the thread local pools. And it gets that advantage because it doesn't free things piecewise, it only frees the entire memory. So in order to get the advantage, you have to have a lifetime cliff where everything goes away at the same time. And that's what makes it nice for transaction because you have that cliff is implicit. So.
Do you see any of this standard memory arena code being replaced by standard code? I mean, libswoc memory arena with a what I thought was supposed to be the standard memory like replacement for this.
I looked at that. It's really pretty inadequate, frankly, the standard ones. What we will be looking at doing once we're off RHEL 7 is tweaking memory arena to do PMR stuff. Right now, we can't do PMR in RHEL 7, so that's not an option. Once we do that, what I'd like to look is using it. Memorina, if you look at the API to Memorina, it's got a lot of nice features in terms of allocating chunks of memory. It also has the nice feature of transient memory where you can say, well, just give me the remains of the buffer. Don't actually allocate. Let me fiddle around with stuff in there. So if you have something that's just very, very temporary, but potentially needs additional memory, you can use that memory and then not having not actually allocated it and then let the next guy do it. The arena.h does this with you can free the last thing. So I put that in more explicitly for Memorina, and it's really nice. And you don't get the GC support. So there's this class results not used a lot of places, but if you're doing error reporting, I think you should look at errata. It's really quite nice. Nubrio, he used it extensively in proxy verifier and was happy with it. I actually rewrote quite a bit of the API to stop him from yelling at me. So this has been through multiple API revisions, and it's looking pretty good now. Let's see. The memstand really is the biggest one that we haven't talked about that I'm going to talk about. So it's kind of like a text view, but it's writable, and so this is a significant difference. It also doesn't let you look inside, so it has no parsing support. It just says, I'm just about chunks of memory, but it does very nice typecasting. It provides array support, so you can take things and turn them from chars to arrays of T and do all sorts of fun stuff. The best thing I want to talk about here is using it as a parameter. The same way you want to use views as parameters, you want to use memspans as writable memory parameters, because then you're not putting any requirements on where this memory came from. It can come from a vector, it can come from a vectray, it can come from the heap, it can come from the stack, it can come from somebody else, right? You don't put any restrictions, so you can avoid allocations upstream because they don't have to sub-allocate. And the biggest one here is it means passing subspans of things becomes trivial. You can just say, oh, I got this chunk of memory, but I only want you to use this piece of it. You can just pass a memspan down, and off you go. So I think this is actually the number one thing. Well, we'll get to that later. Anyway, it has special support for void const. It models pointer semantics. So if I have a memspan of void const, I can assign any memspan to it. I can assign any non-const memspan to memspan void. If you want to go the other way, you have to do a rebind to cast. This is precisely how pointers work. This is why I picked these rules. And the constants, memspan constants and the memory constants are independent, just like a pointer. I can have a const pointer to writable memory and a writable pointer to constant memory. So memspan does the same thing. It's really just a special pointer. All right, let's go to the final notes. Here's a list. I'll have to put this somewhere so that Leif can find it. Use SWOC, don't use standard string parameters unless you really seriously need the standard string specifically. Same with vector, don't use that, use memspan. If you're storing strings rather than mallocing or anything else, I really like just using standard string. If all you need is a chunk of char make a standard string, use that. All the cleanup is handled for you. The resizing is handled for you. It's really just very nice. Don't use tokenizer. Let's avoid requiring C strings. I know I'd have yelled at a couple people the last few months about putting stuff up. Everything should be view oriented, either span oriented or view oriented. We should do that everywhere, whenever possible, and only go to C strings or whatever when we actually have to talk to a system stuff. And again, the whole lib format and buffer writer or standard format lets you do this. You can pass views and spans into them, and they'll just work. You don't need that in alternating byte. It creates lots of problems. Avoid it if at all possible. And I want all the plugin API to be view and span oriented, so that when we put C++ wrappers on top of it, which we're going to do at some point, it's so much easier. You should use the SWOC SV to I and SV to U to do numeric conversions, because again, they handle all the cases. They let you do different bases. They handle views. You don't have to null terminate for them. And so that's really better. And consider errata. That's not as urgent, but it'd be nice if we started using that more. Anyway, that's it. I was going to do some code examples, but we'll just pass on that in order to save time. And please reach out to me. There's, as you saw before, there's documentation for the libswoc stuff. You can reach out to me. So any questions?
Alan, just a quick question. Sorry, maybe I probably missed it because of the speed, but you said don't use standard vector parameters. What was the alternative to that?
Memspan.
Memspan, okay. So that has the same interface for a vector for indexing in? And
for indexing, you should only pass a vector if you want to modify the vector itself. If you want to add or remove elements from the vector, then you have to pass a vector reference.
Sure.
But I see a lot of things where people passing vectors simply get a chunk of memory.
Okay.
So how do you view that different from standard array?
It doesn't, it's non-owning. That's the big difference. So if you have a memspan parameter, you're saying, I don't care, I don't own the memory, I'm just going to manipulate it. And you don't want to require which container it came from. If I have a memspan parameter, I can pass a standard array into it. I can pass a standard vector into it. I can pass another memspan. I can pass some stack memory into it.
Right. You're basically saying it's like, how to say it?
It's genericized.
It's like you said, it's like a string view, but for collections.
Yes. It's like a view, and you want to use it for all the same reasons that views are better than strings, unless you really need to require a container because you want to change the container and not just the memory the container owns. All right, well.
I have a question, Alan.
Yes.
So SWOC is going to replace, like I said, TS, right? A bunch of stuff.
Yes.
Is that all going to get done before 10.0?
I don't know. I will do what I can, but I can't promise that.
Kind of rolling into the next section here, maybe a little bit, but
I am working on it, but
yeah.
Can we
get the community to help out here, maybe?
So just to hit on that subject, Leif, because I think part of what you're getting at here is that what happens if Alan gets hit by a bus,
right?
Or he decides to become a bigger bum than he already is.
Right. Is that possible?
So can we get Alan to work for one of us for a while until we can get some talent to help take over so he can retire as a full-time bum? Alan, hint, hint. Anyways, so.
Well, I'm certainly open to that, either short-term employment or contracting, but I don't think we're going to. Let's see if we have time later to talk about that.
One option, Alan, would be that you make a project, or we can all make a project, right? Part of the 10.0 release, make one specific list there of things and just say, here's all the things that needs to be done. And then you can put a name next to them if anyone volunteers. So like, hey, Walt is going to take on whatever, and Mo is going to take on this other thing, and then at least we don't work on it on the same things.
All right, I made a note to do that.
Why does this need to be done before 10?
Doesn't have to be, but it would be nice because it's a bit of a mess right now, and
it's all internal, so it doesn't really make that much difference, does it?
No, but it makes a difference when you're writing code and you know which path you're gonna take.
Oh, okay. One last thing. Speaking of that just reminded me. I want to strongly emphasize here that libswoc is now available to plugins. So we have a lot less distinction between what we want to use in the core and what we use in plugins, particularly the ink inet stuff. A big reason for replacing that with libswoc is that then we can have the same code. You write the same code in the same way in the plugins and in the core for IP address handling. I know that people cheat and they grab ink inet and it's a mess. But switching to libswoc means that the plugins get all of this stuff, right? And having code, not having to remember whether you're in the core or in the plugins for doing various things, I think is a big win. So errata works in the plugins.
Yeah, that sounds like a great segue to talking about a plugin API that we should be fixing up.
Yeah, that's on my list too.
No, I thought my biggest concern right now is besides cleaning up the API, we should be talking about trying to get an SO for 10. And how we have that structure, because right now we can't link our plugins properly, and that's still causing pain. And it would simplify a lot if we could just get the compiler to do its job instead of trying to tell it to not do its job.
Anyway, all right. I don't want to seem brushy, but we gotta catch up some time. So I think we should move